Section 5, we'll be looking at radicals. If you remember what radicals are, they look exactly like this, as you can see here. This little squiggly. So radicals can be written in exponent notation. And how does that look like? Well, we saw a bit of that last lesson in exponents. But what they look like is the square root of 4 will be an exponent of 1/2. And it doesn't just work for square roots. It can be, for example, radical of the 5th root. That exponent would be 1/5. Like I said, we touched a bit on it before. But now there's more to do with radicals. In this case, we're going to be simplifying big radicals. What that means is radicals who have that have numbers that can be split into multiple factors. In this case, they can be, in any case actually, they can be completely simplified into its prime factors. And we're going to use something called a factorization tree for that. The steps are, number 1, factor the numbers until all of them are prime. The second step is to circle any pair of prime numbers. And the third step is to rewrite radical as its simplest form. So again, let's look at an example. I like to go over examples to pretty much illustrate what it is we have to do. So for example, say we're given the square root of 525. Well, we can definitely split 525 into factors because that number is not a prime number. 525, let's see, what are 2 factors? Now, you can get any 2 factors. In this case, I will choose 5 and 105. So 5 times 105 will equal 525. So I will choose those as my 2 factors. Now 5 is a prime number, so that branch stops there. 105, however, is not a prime number. We can still branch that out into 2 other factors. So let's go ahead and draw those 2 branches there. And in my case, or in this case, I chose 5 and 21. Now, again, 5 is prime, so that branch stops there. 21, however, is not prime. So we can continue factoring out 21, which gives us 3 and 7. And now notice 5 is prime, 5 is prime, 3 is prime, 7 is prime, so our branches stop there. And now we have a little tree. So we're done with step 1, right? It says factor the numbers until all are prime, right? 5, 5, 3, and 7 are all prime. We stop there. We move on to step number 2. Circle any pair of prime numbers. In this case, the pair of prime numbers we have are the 5s. Why are we going to do that? Because when we rewrite square root of 525, that becomes square root of 5 times 5 times 3 times 7. And if we have 5 times 5, that's 5 squared. 5 squared, the square root of 5 squared is just 5. So that 5 there, these 5s become, or I should say, the pair we circled, that number comes out of the radical. Now, because 3 and 7 don't have a pair, they stay inside. And we can just multiply them to have 21. So the square root of 525 reduces to 5 times the square root of 21. That is what we do. That is what is known as a factorization tree. Now, if we start off with, say, a prime number, let's say, I don't know, 11, square root of 11. That cannot be simplified. Reason being is 11 is already prime, so we have no tree. It just stops there. All right, so next is a distributive property. I know radicals can be a bit intimidating, but the multiplication distributive property also applies. All right, I know the squiggly, the radical might intimidate at first, but the same rules apply. And let me show you just how. Here we have square root of 3 times, and in the parentheses you can see 2 times the square root of 3 plus square root of 5. Well, that 3 we can distribute times this and times this. Right, so that equals to this right-hand side. Now in this case, the square root of 3 times the square root of 3, that becomes the square root of 9. So I'm going to rewrite that as 2 times the square root of 9. And then square root of 3 times square root of 5 is the square root of 15. From here, can we do anything more to simplify? Just one more thing. The square root of 9, we know what that is. That is just equal to 3. So we have 2 times 3 plus 15, and we know that 2 times 3, well, that's just a 6. So 6 plus the square root of 15. And that is basically all we can do as far as simplifying goes. Now you may have heard of something known as rationalizing the denominator. They mention this so much in high school. They love to rationalize the denominator in standardized tests. Maybe some you've taken before. All that means is to not have a radical in the denominator when you have a fraction. And how do we rationalize the denominator? Well, as you can see, the hint is telling us multiply the fraction by 1. There's more to it than just that, but let me tell you what I mean. I'll give you an example here. If we have an example, we have 2 over the square root of 3. Just as the hint says, I'm just going to multiply that fraction by 1. But the way I'm going to do it is, instead of just the number 1, I'm going to multiply it by the square root of 3 over the square root of 3, as we do right here. So this is just 1 because anything over itself is just equal to 1. So we're still multiplying by 1. The fraction will not change. What will change is now we can multiply. When we multiply fractions, if you remember, you multiply straight across. So 2 times square root of 3 and square root of 3 times square root of 3. Square root of 3 times square root of 3 now just becomes 3. And in the numerator, we get left with 2 times the square root of 3. So now we no longer have a radical in our denominator. Now it's in our numerator, but that's okay. That's what we call rationalizing the denominator. So whatever you see as your denominator, you'll multiply by 1, by whatever it shows in the denominator, and it'll rationalize it. So this fraction here is the same as this one over here. All we did was rationalize. Okay, after that, we have another example. This one looks a bit more complicated because it is, but not by much. There's another trick we can do with this. What we're going to do with 2 over 3 plus the square root of 6 is something we call multiplying by the conjugate. What does that mean? Well, we're still going to be multiplying by 1, but now using the conjugate. The conjugate is whatever you have in the denominator, you're going to rewrite that, but instead of a positive sign, you're going to write a negative sign. Or if we had a negative sign to begin with, we would write a positive sign. So we're multiplying again by a fraction that's the number over itself, but now it's 3 minus the square root of 6 over 3 minus the square root of 6. That is the conjugate. So let me write here. 3 plus the square root of 6. The conjugate, I'll abbreviate conjugate, is 3 minus the square root of 6. They are the conjugate of each other. Right, so that's what we're multiplying. And again, we're going to multiply straight across. There's a bit more algebra here that goes on, but not much else. 2 times the square root of, 2 times 3 minus the square root of 6. That's in the numerator. In the denominator, we do something with the distributive property. You may have heard of FOIL. That's not the proper name. It's just using the distributive property. But we'll multiply those two binomials to get the denominator. And something we can see here is that we have negative 3 times the square root of 6, and then positive 3 square root of 6. So those two can cancel out. What does that leave us? That leaves us 9 minus the square root of 36 in the denominator. And if you remember, the square root of 36 is equal to 6. So we really have 9 minus 6 in the denominator. And we know that is equal to 3. So we're just going to write 3 in the denominator. And the numerator, well, 2 times 3 is 6. And then 2 times negative square root of 6 just stays as negative square root of 6. No reason to do anything to the numerator. We'll just keep it as is. This is pretty much the simplified version of our fraction as we rationalized the denominator. If you have any questions, this is, again, if you don't recall this from when you first learned it, might take some practice to remember all the steps. But like I said, go ahead and ask questions, ask away. That's why we're here. We want you to learn.